Try it for number 1. The table shows the number of yards y that a professional bicyclist rides in s seconds. Find a pattern that relates the variables. If the cyclist maintains this speed, how far will the cyclist ride in 8 seconds? Very, very similar to what we've been doing. Step 1, identify your pattern and write a rule. Step 2, figure out 8 seconds. Okay, our pattern isn't perfect here. So you can see, look at the pattern. It goes 2 to 3, but we skip. We go 3 to 5, and then we start counting by 1 again, 5 to 6. So when I increase by 1 second, what happened over here? When I increased by 2 seconds, what happened over here? And when I increased by another 1 second, what happened over here? So the goal is to find that pattern. It's kind of hard to find the pattern because 4 is missing, right? But we could probably figure out 4 if we study this enough. So we obviously can find 2 to 3 is an increase of 1, right? So what did we increase from 24.4 to get to 36.6? So one thing you do is you could take your new number that we got to, our 36.6, and subtract the old number. So we've got 36.6, and we're subtracting 24.4. 6 subtract 4 is 2. 6 subtract 4 is 2. 3 subtract 2 is 1. Bring that decimal down. So what we ended up doing, we increased by 12.2 seconds. If we're running a race or if we're biking or whatever it is, are we like machines that always go at the exact same time? So for every second, are we always traveling 12.2 yards? Not always, but maybe this table holds true to that, but we might want to check what is happening with my increase. Okay, so I'm going to do the other 1 second one. We went from 5 seconds to 6 seconds, and that time went from 73.2 to from 61 seconds. So I'm going to put a decimal and a 0 there, right? So I took my new time and subtracted my old time again. I'm hoping it's still 12.2, but we'll have to check. So we're subtracting these. 2 subtract 0 is 2. 3 subtract 1 is 2. 3 subtract 6 is 1. So that's kind of telling me something. Hopefully you're starting to see the pattern. For every second that I go, I am going to travel 12.2 yards. So I told you guys before, I don't like using S's as a variable because they start to look like 5s. So I'm going to kind of change this problem and mark seconds as, let's just do X then, okay? So 12.2, every second that I ride, I go 12.2 yards. Okay, so cool, we found our pattern. What about our time? The question is, how far would they go in 8 seconds? So I'm going to plug 8 into this equation, right? 12.2 times 8 equals some distance in yards. So I got to calculate it. 12 times 2 times 8. 8 times 2 is 16. 8 times 2 again, another 16, but I've got that 1, so 16 plus that 1 is 17. And 8 times 1 is 8, plus that 1, I'm at 9. I got 1 place value here, so I need to move it 1 place value. So it's 97.6 yards. So if I was biking in 8 seconds, I'm going to go 97.6 yards. Okay? We kind of have a follow-up question here. How do you know that the pattern you wrote describes the pattern in the table? So how do you know that this equation that we wrote works for all these numbers in our table? And the reason we know that is we can take any random number and we can plug it in. So I can put 5 into this equation, and what should it equal? It should equal 61. I can put 3 into my equation, and it'll equal 36.6. Plug 2 in the equation, and so on. For any number I plug in this equation, it should match the